Good evening, friends. Now I want to explain today about normality of the solution. What is normality, and also the different formulas, different questions, calculations of normality, and also the different types of normalities, decinormal, centinormal, and also explain about the relation between normality and molarity, and normality in different mixtures, either mixed with same acids to different concentrations, or mixed with acid and base. How the normality will find out. Now I want to explain. First of all, what is the definition of normality? Normality means, what is the definition? Number of gram equivalents present in a solution 1 liter. That is called as a normality. Normality, it is denoted with capital N. The formula N is equal to number of gram equivalents divided by volume of the solution in liter. Volume of the solution in liter. This is called as a normality. How to must remember, it is very important. Normality is equal to number of gram equivalent by volume of the solution in liter. Normality means number of gram equivalent present in a solution of volume 1 liter. This is about the normality. Next, normality is equal to generally gram equivalent, units వచ్చేసి gram equivalent by liters. This is the units for normality. Units for normality is gram equivalents per liter. For example, if you want to calculate question, so if you want to calculate 0.98 grams of H2SO4 present in a 500 ml solution, find normality. This is the question they ask. For this, you have to write down the normality definition. Normality is equal to number of gram equivalent divided by with the volume of the solution in liter. Volume in solution liter. First of all, you have to find out the number of gram equivalent. How you find out? Number of gram equivalent is equal to number of equivalent mass divided by with equivalent mass divided by with what is the equivalent mass? Equivalent mass. Number of gram equivalent is equal to number of equivalent mass divided with molar mass or molecular mass. What is the molar mass? For H2SO4, molar mass is oxygen is 16, sulfur is 32, hydrogen is 1. For H2SO4, 2 into 1 plus sulfur is 32 plus 4 into 16. This is equal to 34 plus 48. 34 plus 64. Total is 98 grams. The molar mass. Number of equivalents is equal to mass of the weight or mass, whatever it may be, mass of molecule compound by divided by with n factor divided molecular mass is 98. Molar mass is 98. Here n factor is x is equal to 2. Why? Because 2 H plus ions are there. That's why mass of the molar mass is mass of the molecule. How much they given? 0.98. 0.98 by 2 divided by 98 means it comes divided with 98. this is equal to 0.98 by 2 into 98. If you this 1 by 200, number of gram equivalents is 1 by this is equivalent mass is equal to molecular mass by 2. This you know, equivalent mass is equal to molecular mass by 2. This is divided with the mass of the molecule by, this is for n factor, mass of the molecule by, just you have to confuse here, number of equivalents, number of mass equivalent by molar mass. This you know, volume of the solution. This number of gram equivalent we have to find out. Number of gram equivalent is equal to mass of number of equivalent by molar mass. Molar mass is, this is number of weight of the, that is mass by, this is mass by equivalent mass, not this number of gram equivalent, mass by equivalent mass, mass by divided by with molecular weight by n factor, means this is equal to mass is 0.98, molecular mass is 98 by n factor means 2, that is 49. This is equal to how much? 0.98. This is equal to 0.98 by 49. This you have to number of gram equivalent. Number of gram equivalent is 0.98 by 49. Volume of the solution in liters. This is how many? 500 ml, means 500 by 1000. You have to convert it into 1000. That is equal to 0.98 by 49 into 1000 by 500. This you have to put. Next, what is the equation? Next we are 500. This is, if you remove the point, this here we get 100. This 2 by 100. Here 500 means this is 2. Means this is 4 by 100. That is equal to 0.04 normal. This is the answer equation solution for the 598 grams of H2SO4 present in 500 ml of solution. Then normality of the solution is 0.04 normal. Once again I will explain. To see 0.98 grams of H2SO4 present in a 500 ml solution, find the normality. Normality definition is, normality is equal to number of gram equivalent into volume of the solution in liters. First of all, you have to find out the number of gram equivalent. Number of gram equivalent is equal to equivalent mass. This is equivalent mass by molar mass or molecular mass. Molar mass or equivalent mass by equivalent. Number of gram equivalent is equal to equivalent mass by, this is molecular weight. Generally, number of moles is equal to, what is the form definition? Number of is equal to moles by mass by molar mass. This we know. Like that, number of gram equivalent is equal to equivalent mass by molecular mass. Next, number of equivalent mass is equal to mass by equivalent mass is equal to equivalent mass is equal to mass by equivalent mass. Mass by molecular weight by n factor. This is the you have to know. Next, mass is given 0.98, molecular weight by n factor. N factor means that is 2. Molecular weight is 98. 98 by 2 means 49. 0.98 by, this is the mass of the equivalent mass. 98 grams of H2SO4, that is the equivalent mass. That is n factor is 2. This is 0.9. This is the number of gram equivalent. You have to substitute here. Then volume is 500. You have to convert it liter by 1000. This is 0.04 normal to get. This is about the how to find out the normality of the solution. Next I will explain about the, if you write different terms of the normality. First of all, if you write normality is equal to, it is one normal, that is equal to 1, normality is equal to 1. This is denoted with n. If in case of decinormal, how you denoted? Decinormal is equal to n is equal to 1 by 10, that is normality is equal to n by 10 if it is decinormal. If it is binormal, binormal means it is denoted with n is equal to 2, that is 2n. If it is centinormal, if it is centinormal, this is n is equal to 1 by 100, this is equal to the n by 100. This is denoted as a centinormal. Next, we have to find out the next one of the question. How to find out this one? Find the mass of sodium hydrogen 250 ml of semi-normal solution. Find the mass of sodium hydroxide present in. Find the mass of sodium hydroxide present in 250 ml of a semi-normal solution. Then how to find out? Find the mass of sodium, weight of the sodium hydroxide present in 250 ml of semi-normal solution. Semi-normal means semi-normal is equal to, normality is equal to 1 by 2 normal. This is the semi-normal, 1 by 2, 0.5 normality. Generally formula we know, normality is equal to number of gram equivalents divided by volume in solution of the volume in liters. Then we have to find out this is normality is 0.5 normal, semi-normal means 0.5. Volume of the solution they has given 250 ml. Then we have to find out the mass of the sodium hydroxide. Number of gram equivalent is equal to molecular gram equivalent mass by number of equivalent mass of the molecule by weight of the molecule or mass of the molecule by number of gram equivalent mass. Number of gram equivalents, we have to find out. Mass of the molecule is how much? We have to find out, that is denoted as x. Number of gram equivalent means number of equivalent mass of sodium is 23, oxygen is 16, hydrogen is 1. This is equal to 40. Molecular weight is 40. Here n factor is equal to, here equivalent mass is equal to, this is the formula, molecular weight by x factor. Here n factor is base, it is 1, x is equal to 1. Here molecular mass is 40 by 1, that's why here it is 40. Number of gram equivalent is x by 40. You put here x by 40. Volume of the solution in liter is 250 ml, 250 by 1000. Here 0.5 is equal to x by 40 into 1000 by 250, 4 for 10. X is equal to, here 5 grams. 5 grams of the weight of the mass of the sodium hydroxide is 5 grams is present in the semi-normal solution. This is about the be given a normal, decinormal or semi-normal. You can find out the solution easily. Wait 2 minutes. Next, discuss about the next we discuss about the relation between normality and molarity. Next we discuss about the relation between normality and molarity. What is the relation between normality and molarity? This is very important. We know molarity is equal to number of moles divided solution in liter. Normality is equal to number of gram equivalents present in solution in volume of the solution present in liters. Then we put the divide with normality with molarity. This solution get cancel. Number of gram equivalent divided with number of moles. This you know. Then normality by molarity is equal to number of gram equivalent is equal to what was that? Mass of the weight of the molecule by molecular compound divided with gram equivalent weight. Gram equivalent mass by mass of the mass by divided with molecular mass. Next we put mass of molecular mass of the compound divided with gram equivalent means that is molar mass equivalent mass divided with X factor. This is equal to molar mass is divided with mass of molecule. This you have to divide. This you get this X factor comes to upside. Normality by molarity is equal to X, means normality is equal to molarity into X factor. This is the very important relation between this is N factor or it is valency. We denoted with the valency of the molecule. Mass of molecule by mass of molecule divided by molecular mass. This is gram equivalent. Gram equivalent divided with the molecular mass, molar mass divided by X. This is the gram equivalent mass. This we get this is converted to molecular mass get cancelled. This is X. X means this is the normality is equal to molarity into X. X means N factor or valency of the molecule. This is the relation between the molarity and the normality. Next we have to find out the if you find the molarity of molarity of 0.2 normal H2SO4 solution. Then we know normality is equal to molarity into X factor or X factor. This is the valency. Here X factor is equal to 2. Why? Because this is H2SO4. This is a 0.2 normal molarity into 2. M is equal to 0.1 molar. This is the solution for this question. Next we discuss about the normality of mixtures. Next we discuss about the normality of mixtures. If you take mixtures, you can write the normality. So here two different types, acid or you can take base. For example, if you take beaker, this is normality N, volume B1, number of equivalent mass is this. Next we put N2 V2, this is also number of equivalent weight, that is resultant. This is N, V1 plus volume is V2 and total. This is the, if you two acid and base you take, mix with, combine, they will give resultant normality is this one. This is normality V1 plus V2 is equal to the N1 V1 plus N2 V2. Then for normality is equal to N1 V1 plus N2 V2 by V1 plus V2. This is the, for the normality. In case of mixtures, either two acids will mix or two bases will mix. This is the formula. I have to find out the normality of the any mixtures. If in case of you take acid, next we take base, here having two conditions will appear here two conditions will appear. One is acid is greater than NbVb, the resultant normality solution will get acidic, more H plus ions because acidic in nature. The concentration of normality is equal to NaVa minus NvVb. If you want to calculate the concentration of that is equal to Va plus Vb. This is the formula for in case of acid. If it is resulting solution is acidic in nature, resulting solution if it is acid, then it will get the normality. If this is the condition, if NaVa is less than NbVb, then resultant solution, concentration of solution is OH minus, basic in nature. This is H plus ion concentration. If it is OH minus concentration, then NbVb minus NaVa by Va plus Vb. This is the concentration for calculation of OH minus. If both are equal, NaVa is equal to NbVb. If it is neutral solution, this is the concentration of equation, that is resulting solution. Based on that, we can solve the many problems. We can get easily the solution. If, for example, if you take any another question, if you take, for example, if it is 0.2 normal 100 ml HCl is mixed with 0.3 normal 200 ml NaOH, then calculate the either H plus or OH minus ion. HCl, this is acid, 100 ml 0.2 NaVa, this is equal to 0.2 into 100. If you want to calculate NbVb, base, 0.3 into 200 ml, this is 20, this is 60, means NbVb is greater than NaVa, basic in nature. Then resultant OH minus concentration is equal to 60 minus 20 by total volume 100 ml to 100 plus 200 means 300 ml. This is equal to 40 by 300. This is the concentration of OH minus ions. Like this we have to calculate the problems. Thank you friends. So far we discussed about the normality, what is the definition for normality, and also the problems on normality, how you calculate the gram equivalent weight. Next after that we calculate the decinormal, centinormal, how it is defined. Next after that relation between molarity and normality, and also in case of mixtures how the normality will discuss in two. If we take two acid or base, if either concentration of acid is greater, then we can find out the H plus ion concentration. If concentration of OH minus negative basic nature increases, then we have to find out the OH minus ion concentration. Thank you friends, this is about the normality.